In the spring of 1952, a massive wall of water pushed against a temporary earth barrier in Montana. Beneath the raging Flathead River, an entire dam project was minutes away from total destruction. A Caterpillar D8 was rapidly sinking into the crest of the barrier. The track spun helplessly as internal water saturation dissolved the soil beneath 21,000 kilograms of heavy steel. The operator faced a terrible choice. If the heavy machine broke through the soft crust, the river would instantly follow. The resulting breach would obliterate the Hungry Horse Dam construction site, lying completely exposed just downstream. Lives and years of labor hung in the balance. This is the forgotten story of the machines that held back a flood. We explore the mechanical tension, the engineering limits, and the extreme risks taken on saturated ground. Welcome to the ultimate test of heavy equipment. But to understand how this crisis happened, we have to go back. The Hungry Horse Project began in 1948, designed to build one of the tallest concrete arch structures in the nation. Before pouring, concrete engineers had to move the South Fork of the Flathead River. They relied on massive earth-moving operations to construct a temporary diversion structure, a massive earth-fill barrier known as a cofferdam. Bureau of Reclamation contractors brought in fleets of crawler tractors. Time equals 400 milliseconds / greater than the Caterpillar D8 was the backbone of this massive effort, utilizing its 148 horsepower to push thousands of yards of rock. These heavy dozers operated relentlessly through the changing seasons. Operators carved haul roads and pushed heavy fill material into the fast-flowing channel, slowly choking off the river to expose the dry bedrock below. The cofferdam was engineered to withstand a standard 50-year flood event. It featured a compacted earth core designed to hold back steady water pressure while the permanent concrete structure rose safely behind it. For years, the system worked exactly as the engineers intended. But the winter of 1951 brought an unprecedented snowpack across the rugged Montana Rockies. Time equals 300 milliseconds / greater than setting the stage for an inevitable catastrophic spring melt. By late April, the runoff began exceeding all predicted forecast levels. Billions of gallons of meltwater rushed into the drainage basin, accelerating the river flow and aggressively testing the limits of the temporary earth structure. The rising reservoir climbed steadily toward the design crest elevation of 3,420 feet. Engineers realized the cofferdam would overtop unless they immediately added emergency fill to raise the height. If you want to see how this bulldozer survived, here's what I ask. See that subscribe button? It is our exchange, your way of saying this reached you. Hit subscribe if this resonated, drop a like if it moved you, and tell us in the comments what you know about the Cat D8. It helps us share more stories like this. Back to the project. The machines were commanded back onto the crest for emergency reinforcement. Operators pushed heavy loads of uncompacted soil, fighting against time to build a higher protective lip before the turbulent river could spill over. But an invisible threat was moving through the dark earth below them. An earth-fill structure under extreme head pressure develops a rising internal water table known scientifically as the phreatic surface. This dynamic saturation drastically weakens the soil. As the upstream water level rose, this internal saturation crept upward toward the crest. The dry material transitioned into a weak mud, losing its structural bearing capacity without showing any obvious surface warnings. A bulldozer operator might feel secure on firm ground in the morning. However, by the afternoon, that exact same section of earth could secretly turn to a soft paste under the immense hydraulic pressure. The mechanical evolution of bulldozers, history's most punishing projects and the technical details no one else covers. That is what lives in the membership section. Join and you get full access to longer deep dives built for people like you. Now back to the Hungry Horse Dam. The heavy tractors continued their critical push across the narrow crest. Every pass added necessary height, but the massive weight of the machines placed tremendous downward stress on the rapidly weakening soil structure. Ground pressure from a crawler tractor is generally well distributed. But when the underlying earth reaches total saturation, even the wide tracks of a D8 can exceed the minimal shear strength of the wet fill. This is exactly what happened to the operator pushing fill near the edge. The right track suddenly broke through the firm crust, sinking deeply into a hidden pocket of highly saturated, unstable ground. He instantly felt the massive heavy machine tilt aggressively toward the riverside. The diesel engine roared as he attempted to reverse, but the spinning steel grousers only dug deeper into the soft mud. Seepage water began bubbling up around the sunken track frames. The hydraulic gradient had finally breached the upper layers, creating a highly dangerous zone where heavy equipment operations could trigger a catastrophic structural failure. Project engineers rushed to the unstable area to assess the damage. They quickly realized that the combined load of the emergency fill and the massive tractors was now threatening the basic integrity of the dam. Pushing more dirt with heavy crawler machines was no longer an option. The engineering limit had been reached, and continuing the mechanical compaction process would simply cause the entire saturated crest to shear away. It was a terrifying mechanical trade-off. They had to abandon the dense compaction provided by the heavy steel tracks, accepting a looser soil fill to immediately remove the excessive weight from the vulnerable crest. Supervisors made the critical call to halt all dozer activity on the upper fill. Operators carefully backed their massive rigs away from the saturated zones, watching the ground flex and bleed water beneath them. Retreating from the front line went against every instinct of these seasoned operators. Time equals ___quote _101 / greater than. However, leaving the heavy machines on top of a crumbling foundation was an unacceptable risk that could have killed multiple crews. With the bulldozers safely removed, the strategy completely shifted. Dump trucks began carefully backing up to the edge, dropping loose uncompacted earth directly onto the crest without any heavy machinery pushing or spreading it. This loose material offered significantly less resistance to flowing water, but it provided the crucial extra inches of elevation without adding the devastating ground pressure of 21,000-kilogram tractors grinding across the surface. The river continued its relentless climb throughout the tense afternoon. Every worker on site watched the water edge closer to the loose dirt, waiting for the inevitable moment when the temporary dam might finally collapse. Saturated earth groaned under the immense strain of the rising reservoir. The seepage along the downstream face accelerated, creating small rivers of muddy water that threatened to wash away the foundation from the inside out. Yet the hastily dumped earth somehow held its fragile ground. The absence of the heavy tractors allowed the saturated core to maintain its final remaining fraction of structural stability during the absolute peak pressure. By nightfall, the surging floodwaters miraculously stopped rising. The river crested exactly 8 inches below the emergency reinforced elevation, sparing the downstream construction site from an absolute and catastrophic total wipeout. The gambit had worked perfectly. If this story meant something to you, maybe buy me a coffee while I build the next one. Hit the thanks button below. It is a small gesture, but it tells me this reached you. Let us continue with the D8 operators. When the morning sun finally illuminated the Flathead River basin, the true scale of the victory became visible. The massive cofferdam was bruised and actively leaking, but the massive wall of earth remained firmly intact. Below the diversion structure, the deep excavation site was completely dry. The foundation work for the towering concrete arch dam was entirely preserved, saving millions of dollars and potentially dozens of human lives. The decision to pull the heavy machinery off the crest became legendary. It served as a vital case study in civil engineering, proving that sometimes knowing when to stop a machine is the ultimate skill. The Bureau of Reclamation updated their emergency response protocols based on this event. Hungry Horse proved that mechanical compaction limits on saturated structures required totally different calculations than standard dry earth moving operations. As the floodwaters slowly receded, the sturdy D8 tractors were brought back down to the lower roads. They immediately resumed their punishing daily work, repairing access paths and clearing away the massive storm debris. These machines were never designed to be delicate instruments, yet their sheer power and weight forced engineers to calculate exact failure thresholds, linking raw mechanical force with complex geological fluid dynamics. It was a brilliant balance. In 1953, the massive Hungry Horse Dam was officially completed on schedule. Standing 564 feet tall, it became one of the most vital hydroelectric power providers in the entire American West. The temporary diversion cofferdam was eventually breached and completely submerged. The tons of earth and rock pushed by those dedicated operators now sit quietly at the dark bottom of the massive modern reservoir. The Caterpillar D8 models from that era slowly faded from standard commercial use. Many were run until their engines seized, while others were sold off to smaller private logging outfits deep in the high mountains. But the mechanical legacy of that desperate spring remains undeniable. The operators who pushed wet earth against a raging river demonstrated an incredible blend of raw courage and highly precise mechanical intuition. Their actions defined a generation. Heavy equipment. History is rarely built in perfectly controlled environments. It is forged in the mud under intense pressure when a 20-ton steel machine is the only thing standing between safety and total devastation. Today, modern earth-moving relies on advanced sensors and GPS mapping. However, no computer can truly replace the instinct of an operator feeling the ground give way beneath massive steel tracks in the freezing darkness. We remember the machines, but we must also honor the minds that directed them. The Hungry Horse incident stands as a testament to the powerful alliance between rugged industrial engineering and human determination. The massive concrete arch still holds back the Flathead River today. Time equals __, quote, _175, _/ greater than. It is a silent monument to the operators who held the line when the water was rising and the earth was falling apart. If this story moved you, please like and subscribe. Your support helps us preserve these machines and the histories behind them. Tell us in the comments where you're watching from.